somewhere beneath you the ocean goes dark. Not gradually, not softly, but completely, as though someone drew a curtain across the light and simply left it there. Below the sunlit shallows, below the dim blue of the middle waters, there is a place where pressure becomes presence, where silence becomes something you can almost feel against your skin, and in that darkness, things move. They have been moving for longer than our species has had words for night, longer than our earliest ancestors walked upright on the plains, longer, in some cases, us than the continents arrived at their current positions. They are sharks, not monsters, not villains, not the creatures Hollywood taught us to fear with swelling brass and blood in the water. They are something quieter and stranger, and far more extraordinary than that. Tonight, we will meet them one by one. The giants, the deep wanderers, the patient hunters, the ancient ones. We will settle into the slow rhythm of deep water and let each creature reveal itself in its own time. Let your breath slow with the ocean. We'll let the weight of the day lift from your shoulders the way sediment lifts from the seafloor in a passing current. The sharks are already waiting. Number 1. The great white shark, Carcharodon carcharias. It begins as a shape in the gray. Not dramatic, not sudden. Just a density that was not there before, growing slowly clearer, until you understand that something very large is moving toward you through the cold water. The great white shark. Even the name carries weight. It has been earning that weight for over 16 million years. A fully grown female, and it is the females who grow largest, can reach 6 meters in length and weigh more than 2,000 kilograms. To stand beside one on a scale would be to stand beside a small car. And yet in water, it moves the way thought moves, instantly, completely, without apparent effort. The great white is found in nearly every ocean on Earth, from the cold upwelling waters off South Africa and California to the temperate seas around Australia and the Mediterranean. It follows 2 things: prey and temperature. The ocean is its map and its reason. Its body is a study in contrasts, and the back is a deep charcoal gray, the exact color of shadow on the seafloor, of deep water seen from above. The belly is white, brilliant white, the color of diffused sunlight from below. This arrangement, called countershading, makes the shark nearly invisible from every angle. From above, it disappears into the dark. From below, it vanishes into the light. It is not camouflage in the way a flounder lies flat and mimics sand. It is something more elegant, a calibration of light against light, dark against dark. The shark does not hide. It simply becomes part of the ocean's visual logic. Yet the great white's most famous feature, its teeth, are themselves a kind of architecture. They are serrated, triangular, and arranged in multiple rows. When one tooth breaks or wears down, another rotates forward to replace it, like cards in a deck shuffling endlessly forward. A shark may go through 30,000 teeth in a lifetime, but teeth are not the great white's most important sense. That distinction belongs to something far stranger. Along its snout and scattered across its head are hundreds of tiny gel-filled pores, called the ampullae of Lorenzini. These organs detect electrical fields, the faint bioelectric signature produced by every living muscle in the ocean. A shark can sense a heartbeat through sand. It can feel the electrical twitch of a hidden fish from meters away in total darkness. The great white is also one of a small number of sharks that can maintain a body temperature warmer than the surrounding water, a trait called regional endothermy. This warming, focused in the brain and muscles, gives the great white an advantage in cold water that most fish simply cannot match. It thinks more clearly. It reacts more quickly. The cold that slows its prey does not slow the hunter. Studies tracking individual great whites with satellite tags have revealed something quietly astonishing. These sharks are travelers on a truly oceanic scale. One shark, tagged off the California coast, was recorded swimming to Hawaii and back more than 8,000 kilometers in a matter of months. Another regularly crossed between South Africa and Australia, as they navigate the open ocean with a precision that science is still working to fully explain. A great white shark is, on average, 23 to 25 years old when it reaches full maturity. Some individuals are believed to live 70 years or more. Think of what a 70-year-old great white has witnessed: the warming of the oceans, the decline of fish populations, the arrival and departure of generations of whales. It is, in its own unhurried way, an elder of the deep. When we imagine what lies beneath the surface of the sea, it is often the great white that rises first to mind. Not because it is the most dangerous, statistically, as the ocean offers 100 more urgent threats to human life, but because it represents something primal, a reminder that we are not out there at the top of anything, that the ocean has its own hierarchies, its own quiet rules. The great white does not hate us, it does not think of us at all. We are simply another shape in the water, occasionally investigated, usually dismissed. Let that thought sit with you as the water grows still. Something enormous and patient and perfectly designed, moving through the dark with absolute calm. Number 2. The whale shark, Durincodon typus. Not every giant is a predator. Some move through the world with their mouths open, drawing in the smallest things the ocean has to offer, and growing enormous on almost nothing at all. The whale shark is the largest fish on Earth. Not the largest shark, the largest fish, full stop. A mature whale shark can reach 18 meters in length and weigh more than 20 tons. It is longer than a school bus. It is heavier than 3 full-grown elephants, and it feeds primarily on plankton. This is one of nature's more startling jokes, or perhaps its most elegant jokes. The biggest mouth in the fish world opens not to take prey of any consequence, but to strain microscopic organisms from the water like a slow, breathing net. The whale shark's body is unmistakable. Its back is a deep blue-gray or dark brown, covered in a scattering of pale white spots and stripes arranged in a pattern as individual as a fingerprint. No two whale sharks have the same spot pattern. Researchers now photograph the constellations of spots behind each shark's gills and use pattern recognition software, originally developed for mapping stars, to identify individuals. The whale shark's mouth is at the very front of its head, not tucked beneath the snout like most sharks, but forward-facing, wide and nearly flat. When feeding, it opens this mouth to nearly 1.5 meters across and swims slowly through concentrations of prey. Water flows in, passes through the gill rakers, which act as a fine sieve, and the plankton, fish eggs, krill, and small fish are retained, and the water flows out through the gills. The whale shark barely needs to chew. It is a filter feeder, like the basking shark and the megamouth, patient, methodical, unhurried. It sometimes feeds in a near vertical position, tail down, pumping water through its gills in slow, rhythmic pulses. It can also actively ram filter, cruising steadily through a bloom of prey. Either way, the impression is less of hunting and more of harvesting. a great slow gather of the sea's abundance. Whale sharks are found across the tropical and warm temperate oceans of the world, so they aggregate in predictable locations where prey concentrations are high, off the coast of the Yucatan Peninsula during the spawning of certain fish, in Western Australia's Ningaloo Reef, around the islands of the Maldives. In these places, local diving industries have grown up around them. Swimming alongside a whale shark, maintaining a respectful distance, matching its slow pace, watching its tail sweep slowly side to side, is described by those who have done it as among the most humbling experiences the natural world offers. Despite their size, whale sharks are gentle, and they do not perceive humans as a threat or as prey. They may be curious. They may approach, slow down, hold still for a moment. Then they turn, slowly, and go back to whatever they were doing before. We know frustratingly little about whale shark reproduction. We have never observed one giving birth. We have found a single pregnant female, carrying more than 300 pups at various stages of development. A discovery that overturned the assumption that whale sharks were oviparous, egg-laying. They appear to be ovoviviparous. The eggs hatch inside the mother, and the live young are born into the open ocean. And where they go, how they spend their first years, how long they take to mature, these remain open questions. A whale shark's lifespan is estimated at between 100 and 150 years. They reach sexual maturity around 30 years of age. They are, in every meaningful sense, among the longest lived animals on our planet, and yet we have never watched one grow old. The whale shark carries its years in the quiet way the ocean carries everything, without announcing them, without ceremony. It simply continues, opening its great mouth, drawing in the sea's small offerings, as growing more vast and more patient with each slow pass through the warm blue water. Number 3. The basking shark, Saturninus maximus. In the cold waters off Scotland, off Ireland, off the coast of Norway, and the tip of Newfoundland, something vast and slow moves just below the surface. Its dorsal fin breaks the waterline first, then the snout. Then, if the water is clear enough, the outline of something enormous moving through the gray-green sea with extraordinary patience. The basking shark, the second largest fish in the world. A basking shark can reach 12 to 14 meters in length and weigh up to 7 tons. Its body is heavy, its color a dull gray-brown, its skin rough with millions of tiny tooth-like scales called denticles. It looks at first glance like a creature built for slowness, and in some ways it is, but only in some ways. The basking shark feeds, like the whale shark, on plankton and zooplankton, but it does so differently. It simply opens its enormous mouth, which can be over a meter wide, and swims forward. But the water flows continuously in and through the gill rakers, which are brush-like and closely spaced. A basking shark filters more than 2,000 tons of water per hour when feeding. It is a living strainer, moving through the richest layers of the sea. In summer, basking sharks appear at the surface in remarkable numbers near coastal areas of the North Atlantic. They come for the plankton blooms that develop in the warming water, and they move through these blooms in a peculiar, almost ritual-seeming procession, following each other nose to tail in long lines or slowly circling in loose groups. For centuries, fishermen and coastal communities who witnessed these gatherings did not know what to make of them. The sharks were too large to be ordinary fish, too slow to be predators, too plentiful to be rare. In winter, basking sharks largely disappear from the surface record. For a long time, scientists believed they hibernated in deep water, lying dormant on the seafloor. Tagging studies have since revealed something more extraordinary. They descend to great depths, sometimes beyond 1,000 meters, and continue to travel through the winter months, migrating south toward warmer waters, following deep-water plankton layers, covering distances of thousands of kilometers in the cold and dark. The basking shark sheds and regrows its gill rakers seasonally. During winter, when filter feeding is less productive, the rakers may be lost and regrown in spring. An almost unbelievable act of biological renewal for an animal of this size. The mechanism and its full purpose are still being studied. Basking sharks are slow to reproduce. Gestation is believed to last between 1 and 3 years, one of the longest of any animal. They reach maturity only after many years of growth. They are, as a result, extraordinarily vulnerable to hunting pressure, and for much of the 20th century, basking sharks were killed in large numbers for their liver oil, which was used as a lubricant and lamp fuel. Some populations have not recovered. Today, basking sharks are protected in many parts of the world, and their encounters with humans are, more often than not, peaceful and strange. Two kinds of creature drifting through the same cold water, each trying to make sense of the other. There is something about the basking shark that invites stillness. It asks nothing of you. It is not spectacular in the way of the great white, not technicolor in the way of the whale shark. It is gray, and slow, and enormous, and it moves through the cold North Atlantic like a question no one has quite answered yet. Number 4. The Greenland shark, Somniosis microcephalus. Now we go down. Below the surface light, below the thermocline, below the range where most sharks venture, into water so cold it hovers just above freezing, into the deep black of the Arctic Sea. Something is moving down here, very slowly. The Greenland shark moves at an average speed of approximately 1 kilometer per hour. This is slower than a person walks, slower than a gentle drift. It is, by some measures, the slowest recorded swimming speed of any shark species. And yet, it survives, and yet it grows over centuries to reach 6 meters in length. And yet it is here, in the abyss, in the dark, in the cold, perfectly still in its almost stillness. The Greenland shark may be the longest-lived vertebrate animal on Earth. In 2016, a study published in the journal Science used radiocarbon dating of islands proteins to estimate the age of Greenland sharks. The oldest individual studied was estimated to be approximately 392 years old, with a confidence interval suggesting anywhere from 270 to 512 years. The study's midpoint estimate places the shark's birth sometime around 1627, when Galileo was still alive, when the Pilgrims had only just arrived in New England, when the 30 Years' War was still being fought in Europe. Let that settle, the way deep water lets things settle. A Greenland shark alive today may have been born before your country existed, before the Industrial Revolution, before most of the world's major cities reached their current form. It has moved through the Arctic dark, barely faster than a drifting snowflake, across the entire arc of what we call modern history. The shark's eyes are often clouded by a parasitic copepod, a tiny crustacean called Omatocoita elongata that attaches to the cornea and causes significant visual damage. The Greenland shark is believed to be nearly blind. It hunts, if hunt is even the right word, largely through smell and the detection of electrical fields. Seal remains are frequently found in Greenland shark stomachs, Though how a shark moving at 1 kilometer per hour catches an alert, agile seal remains genuinely puzzling. The prevailing theory is that the shark ambushes sleeping seals, hovering beneath them in the dark, waiting for a duration of time we cannot begin to imagine. The Greenland shark's flesh is toxic to humans if eaten raw due to high concentrations of trimethylamine oxide, a compound that prevents the shark's cells from being crushed by the extreme pressure of deep water. In Iceland, and this flesh is fermented for months to neutralize the toxins, and the resulting food, hakarl, is considered a cultural delicacy, though most who try it for the first time describe the experience as challenging. The Greenland shark does not hurry. It has never hurried. In its 3 or 4 or 5 centuries of existence, it has existed in a time frame that simply does not align with the rhythms of the surface world. It does not know about us, or our urgency, or our sense that things must happen quickly to matter. In the deep cold dark, it simply continues, patient as geology, old as the ice above it. Our number 5, the tiger shark. Galliacerdo Cuvier. The tiger shark arrives without announcing itself. It moves through the warm, shallow water of tropical coastlines, through reef channels and seagrass beds, past mangrove roots, along sandy flats, with the unhurried confidence of an animal that has nothing to prove. At up to 5 meters and more than 500 kilograms, the tiger shark is the 4th largest shark species and the 2nd most recorded in attacks on humans. But numbers can mislead. The tiger shark is not aggressive in the way the word implies. It is thorough. It investigates. It does not readily let go of an investigation. Its name comes from the dark, vertical stripes along its flanks, stripes most visible in juveniles and young adults, fading as the animal matures. In the water, in certain light, these markings create the same visual disruption that stripes create on land, breaking up the outline, confusing the eye, making something that is very much there seem briefly, improbably, uncertain. The tiger shark is one of the least selective feeders of any large marine animal. Its stomach contents read like an inventory of confusion: sea turtles, dolphins, seabirds, stingrays, squid, fish, smaller sharks, sea snakes, horseshoe crabs, and, notoriously, an assortment of human artifacts, license plates, boat parts, clothing, rubber tires. This has earned it the common name garbage can of the sea, which is unkind but not entirely inaccurate. But the tiger shark's willingness to eat nearly anything conceals something of genuine ecological importance. Sea turtles, which are among the tiger shark's preferred prey, graze on seagrass beds. Without predation pressure, sea turtle populations in certain areas overgraze these meadows. The presence of tiger sharks, even just the fear of tiger sharks, causes turtles to alter their feeding behavior, distributing their grazing more evenly across the seagrass, allowing it to recover. This phenomenon, called the ecology of fear, means that the tiger shark shapes the ocean floor simply by existing. Tiger sharks are highly migratory, but not in the simple linear way of many species. They move between coastal and offshore environments, between shallow and deep water, across enormous distances, in patterns that seem to respond to prey availability, water temperature, and breeding cycles. Some individuals tagged in Hawaii have been tracked making long open ocean transits before returning. They understand their ocean with a fluency we are only beginning to map. The tiger shark gives birth to live young, litters of between 10 and 80 pups, born after a gestation period of 14 to 16 months. The pups emerge fully formed, already equipped with the tools of survival, and immediately independent. There is no maternal care, no guidance. The ocean is their first and only teacher. At night, tiger sharks move into shallower water. The surf zone, the reef flat, the sandy margins where humans also sometimes walk and swim. In this sense, and almost only in this sense, the tiger shark and humanity genuinely occupy the same space. It is worth remembering in that space what the tiger shark is doing. It is not hunting us. It is hunting what it has always hunted. We have simply arrived in the same place at the same time, in the same dark water. Number 6. At the bull shark, Carcharhanus lucus. Of all the sharks we will meet tonight, only one routinely enters fresh water. The bull shark is compact, heavy, and built like its name. Blunt-nosed, thick through the shoulders, with a demeanor that has led behaviorists to describe it as one of the most reliably assertive sharks in any ocean. Bull sharks have been found in the Mississippi River, over 1,000 kilometers from the Gulf of Mexico. They inhabit the Ganges and Brahmaputra rivers of India and Bangladesh, where they have been responsible for attacks historically attributed to the so-called Ganges shark, a largely mythologized species. They live in Lake Nicaragua, which was for many years believed to contain a landlocked population of freshwater sharks that had evolved independently. We now know they simply swim in from the Caribbean, through the San Juan River, making journeys in both directions. The ability to tolerate fresh water is exceptionally rare among sharks. Most species regulate salt and water through a process tightly calibrated to seawater conditions. The bull shark has evolved a suite of physiological adaptations in its kidneys, its rectal glands, its liver, that allow it to adjust its internal chemistry depending on the salinity of its environment. It can make this adjustment in both directions, transitioning from salt to fresh and back again over a period of days. This means that the bull shark occupies a greater variety of habitats than almost any other large predator in the world. It can appear in estuaries, in river systems, in urban harbors, in coastal surf zones, so in shallow tropical lagoons, and in the open ocean. It follows food with a pragmatic flexibility that is, depending on your perspective, either admirable or disconcerting. The bull shark reaches up to 3.5 meters in length and can weigh over 300 kilograms. Its hunting style tends to be direct and persistent. It does not often make a single exploratory pass and retreat. When it bites, it tends to bite again. This is the source of its reputation. The bull shark is responsible for more recorded attacks on humans than any other species when proximity to human activity is factored in. It lives where we swim. It feeds where we fish. It moves through the rivers we use for transport and recreation. The overlap is not incidental. It is structural. And yet, even for the bull shark, attacks on humans are vanishingly rare, relative to the number of encounters that do not result in conflict. The shark is not prowling for us. We are simply, occasionally, in the way. The bull shark is also surprisingly poorly studied relative to its fame. Its internal life, its social behaviors, its full reproductive biology, these are incompletely understood. We know it is present in dozens of major river systems. And we know it can navigate from the sea to the interior of continents. We know it is adaptable to a degree almost unmatched among cartilaginous fish. What we do not fully know is why it wanders so far from the salt. What draws a bull shark up a dark river, past the smell of freshwater fish and mud and vegetation, into territory so far from its origins? The river does not answer. The bull shark does not explain. It simply turns upstream and keeps swimming. Number 7. The hammerhead sharks, family Sphyrnidae. Among the ocean's many improbable designs, and the hammerhead is perhaps the most audacious, 9 species of hammerhead shark exist, all belonging to the family Sphyrnidae, named for the Greek word for hammer. They range from the small bonnethead, barely a meter long, to the great hammerhead, which can reach 6 meters and weigh 500 kilograms or more. All of them share the same defining feature: a head flattened and extended laterally into the distinctive cephalofoil, the wide, flattened hammer that gives the family its name. Why? It is a question scientists have been asking since the first naturalists drew one. And the answer turns out to be both practical and elegant. The hammer is sensory equipment. Spread across its wide surface are thousands of ampullae of Lorenzini, the electroreceptor organs that detect bioelectric fields. Because these receptors are spread so widely apart, the hammerhead can sweep them across the seafloor like a metal detector, covering a large area with each slow swing of its head. It is, in effect, a living scanner. Its primary prey includes stingrays, animals that lie buried in the sand and are, to most predators, effectively invisible. The hammerhead sweeps its head across the seafloor and reads the stingray's heartbeat through the sand. Then it pins the ray to the bottom with its hammer, using its leverage and weight to hold it in place, often eating it from the edges inward before it can escape. So the stingray's venom delivered through its tail barb does not deter the shark. Hammerheads are frequently found with multiple barbs embedded in their mouths and throats, evidence of repeated encounters. The wide head also improves hydrodynamic performance. The cephalofoil acts as a bowplane, generating lift and making sharp vertical turns easier. Hammerheads can maneuver in ways that a conventionally shaped shark cannot. They turn faster, dive more steeply, and hold a position in currents with less effort. The great hammerhead is a solitary predator, moving through deep and shallow water alone. But the scalloped hammerhead, slightly smaller, its head edged with a scalloped profile, forms some of the most spectacular aggregations in the shark world. Hundreds, and occasionally thousands, of scalloped hammerheads gather in dense schools around seamounts in the Pacific, the Red Sea, and the waters of the Galapagos and Cocos Islands. These schools are dominated by females. The males come to the edges, performing body movements, shuddering, spiraling, torquing, that are believed to be courtship displays. The meaning of these gatherings, whether they are breeding sites, navigation waypoints, cleaning stations, or something we have not yet categorized, is not fully agreed upon. The sharks arrive in their thousands, circle the seamounts in slow spirals, and then disperse. The ocean records nothing. Hammerhead populations globally are in serious decline due to targeted fishing for their large, valuable fins, and bycatch in longline fisheries. Some species have declined by 70 to 90% over the past few decades. They are among the most threatened large sharks in the world. To imagine the ocean without hammerheads requires imagining a world without one of its most extraordinary designs. A creature that looked at the problem of sensing the world and chose a solution no engineer would have predicted. Wide, lateral, strange, perfectly itself. Number 8. The oceanic white-tip shark, Carcharhinus longimanus. There are places in the ocean with no land in any direction, no island, no reef, no shallow water within reach, just open blue in every direction and depth beneath you measured in kilometers. This is the oceanic whitetip's home. It is built for the open ocean in a way that few sharks are. Its pectoral fins are extraordinarily long, extending like wings, rounded at the tips and pale white, giving the species its name. These long fins are not for speed, and they allow the shark to hang in the water column, to glide, to cover vast distances with minimal energy expenditure. The open ocean is vast and largely empty of prey. The oceanic whitetip conserves everything. It was once among the most abundant large animals on Earth. In the mid-20th century, the oceanic whitetip was considered the most common large pelagic shark in tropical waters. The oceanographer Jacques Cousteau described it as the most dangerous of all sharks, not because of aggression, but because of its persistence. It does not perform the exploratory bump and release of some sharks, yet when it encounters something interesting, it does not easily disengage. This persistence became legendary in the context of maritime disasters. Survivors of shipwrecks and plane crashes in the open ocean have reported oceanic whitetips gathering within hours of an event, drawn by the sounds of distress, the blood, the commotion. In the Second World War, the sinking of several vessels in shark-populated waters led to incidents involving large numbers of whitetips and enormous loss of life. The USS Indianapolis, torpedoed in 1945 with roughly 900 men in the water, is the most cited example, and the sharks that gathered were primarily oceanic whitetips. This history has complicated the oceanic whitetip story. It became, for a time, a symbol of menace. And in that same period, through the mid to late 20th century, it was targeted directly and as bycatch, with catastrophic results. Current estimates suggest oceanic whitetip populations have declined by more than 95% since the 1950s. It is now listed as critically endangered. The shark that was once everywhere in the open ocean is now rarely seen. The blue water it once patrolled in vast numbers is quieter than it should be. An absence has taken the shape of a shark. Conservation efforts are underway, and recent data from some areas suggests slow recovery. But the oceanic whitetip is a sobering reminder that even abundance is not a guarantee, that even something that seems like it will always be there can, in a few decades, become a memory. Number 9. The mako shark, Isurus oxyrhynchus, Isurus paucus. Speed in the ocean is a luxury. Water is 800 times denser than air. Every movement costs something. Vast animals must either be very efficient or very well fed. The mako shark is both. There are two species of mako, the short-fin mako and the long-fin mako. The short-fin is better known, more studied, more feared, and more remarkable. It is the fastest shark in the ocean. Estimates of the short-fin mako's top speed vary between studies and methodologies, but figures of 50 to 60 kilometers per hour are commonly cited, with bursts possibly higher. To put this in context, that is, fast enough to launch a mako completely out of the water when pursuing prey near the surface, something that has been observed and documented. Short-fin mako, in full pursuit of a tuna, can become briefly airborne. The mako's body is built around this speed. It is streamlined to a degree that appears almost theoretical, narrow, smooth, with a perfectly crescentic tail whose upper and lower lobes are nearly equal in length, a design that maximizes thrust without drag. Its skin is so hydrodynamically refined that engineers studying its microscopic structure have drawn on it in the design of competitive swimwear and aircraft surfaces. Like the great white, and the mako is regionally endothermic. It maintains elevated temperatures in its muscles and brain. In cold water, this gives it an overwhelming advantage over the fish it hunts. Bluefin tuna, among the fastest fish in the ocean, capable of 60 kilometers per hour themselves, are among the mako's prey. The two animals are evenly matched in speed. What the mako adds is the warmer muscle, the faster reaction, the ability to sustain pursuit in cold water where tuna begin to slow. A hooked mako is considered one of the most spectacular game fish in the sea. It leaps repeatedly, sometimes to heights of 6 meters above the surface. He's shaking its head, reversing direction, fighting with a ferocity that experienced anglers describe with something close to reverence. For this reason, it has been heavily targeted by sport fishing, compounding pressure from commercial bycatch. Both mako species are now listed as endangered. Their slow reproductive rate, females mature at 18 years, gestation lasts 15 to 18 months, and litters are small, means populations cannot recover quickly from overexploitation. A fishery that removes makos faster than they can reproduce is effectively mining a non-renewable resource. In the open blue water, far from any coastline, the short-fin mako still streaks after its prey at speeds that seem to defy the ocean's resistance. It is, in its element, one of the most purely kinetic creatures on Earth. There is something beautiful about an animal perfectly designed for one thing, speed and the hunt, existing at the edge of its world with everything it has. Number 10. The slow ones. Nurse shark, wabagong, and zebra shark. Not every large shark is built for the open water. Some have made peace with the reef, the sand, the small and crowded world of the shallows. So the nurse shark, Ginglimostoma serratum, is perhaps the most unhurried large shark in the ocean. It can reach up to 4 meters in length and spends most of its time lying on the seafloor, often in piles, individuals resting draped across each other in a way that looks, to a human eye, extraordinarily comfortable. The nurse shark is nocturnal, emerging at night to hunt fish, crustaceans, and mollusks from the reef. It uses suction feeding, expanding its throat rapidly to create a vacuum powerful enough to pull prey from crevices in the coral that would seem impossible to access. It can also breathe without swimming, pumping water across its gills by opening and closing its mouth. This allows it to rest on the seafloor indefinitely, a capacity most sharks lack. Nurse sharks are commonly encountered by divers throughout the tropical Atlantic and eastern Pacific. They are docile enough that inexperienced divers sometimes attempt to touch them, so which is inadvisable. Nurse sharks bite when provoked, and their grip, once applied, is extremely difficult to disengage. The wabagong sharks, of which there are 12 species found primarily in Australian and Southeast Asian waters, take reef camouflage to an extreme. They are carpet sharks in the most literal sense, flattened, broad, fringed with skin filaments along their margins that break up their outline completely. Lying on the seafloor among coral rubble, algae, and sand, a wabagong is essentially invisible. Fish swim over them, around them, and occasionally too close to them, at which point the wabagong's ambush is among the fastest of any shark, a strike measured in milliseconds. The zebra shark, Stygostoma tigrinum, is named for the stripes of its youth, bright yellow and dark brown, conspicuous and beautiful. As the animal matures, these stripes break into spots, and the adult becomes a creature of subtle gold and brown, long-tailed, slender, patrolling the reefs of the Indo-Pacific with a gentle, almost sleepy grace. It, too, feeds by suction, extracting mollusks and crustaceans from coral by inserting its small, flexible mouth into crevices. These slower sharks remind us that there is more than one way to be a shark. The great white's explosive ambush, the mako's sustained pursuit, the hammerhead's sensory sweep. These are strategies, not definitions. A shark is also a patient form resting on a sun-warmed reef, a fringed carpet of camouflage lying still as stone, a spotted shadow moving gently through the coral at dusk. Number 11. The deep ones. Blunt-nosed sixgill and Pacific sleeper shark. We go down again. Deeper this time. The blunt-nosed sixgill shark, Hexanchus griseus, is a relic. And while most modern sharks have 5 gill slits, the sixgill has 6, placing it among the most anatomically ancient sharks alive today. Its ancestors are found in the fossil record from nearly 200 million years ago. It predates the dinosaurs. The sixgill reaches up to 5.5 meters and can weigh over 600 kilograms. It lives primarily in deep water, from 200 meters to beyond 2,000, and is only occasionally seen near the surface at night when it rises to feed. In those rare surface appearances, it has been observed hunting seals and fish in the darkness with a slow, deliberate patience that matches the abyssal environment it usually inhabits. The sixgill has broad, comb-like teeth on its lower jaw, teeth unlike those of any other living shark. Each tooth has multiple cusps arranged in a saw-like row, allowing it to slice through tough prey. It eats fish, squid, rays, smaller sharks, and marine mammals. In the deep, there's a great deal of time between meals. The sixgill's metabolism is calibrated for this interval, burning its reserves slowly, moving through the cold dark at the pace the deep requires. While the Pacific sleeper shark, Somniosus pacificus, belongs to the same family as the Greenland shark and shares many of its traits. Slow-moving, cold water, capable of extremely deep dives, long-lived, and carrying the same toxic flesh that must be processed before consumption. It can reach over 7 meters in length. It has been filmed by deep-sea cameras eating whale carcasses on the sea floor, moving in from the dark, circling slowly, tearing free large chunks of blubber with a rolling bite that uses the shark's own body weight as leverage. These deep sharks exist in a world we have barely entered. Our deepest submersible dives last hours. The sharks have been there for centuries. What they know about the deep ocean, through lived experience, through the memory encoded in their senses, is something we have no instrument to measure. They are not waiting for us down there. They do not notice our absence. They are simply there in the black and the cold, doing what they have done since before our species existed. Number 12. The shadow that was. Otodus megalodon. Before we close, we must speak of the one that is no longer here, or Otodus megalodon. The megalodon was not simply a large great white shark. That comparison, popular in documentary filmmaking and speculative fiction, does a disservice to both animals. The megalodon was a distinct species, belonging to a different genus, with a different body plan, different prey ecology, and a different history. It was, by any measure, the most formidable macro-predator in the ocean's history. Conservative estimates place its maximum length at 15 to 18 meters. Some analyses of tooth-to-body ratios suggest individuals up to 20 meters. It weighed perhaps 60 to 100 tons. Its teeth, triangular and serrated like the great whites but vastly larger, some exceeding 18 centimeters, are the primary evidence of its existence, as shark skeletons are made of cartilage and do not readily fossilize. The megalodon hunted whales. This is the most important sentence in understanding what it was. Not fish, not seals, not the medium-sized prey of modern apex predators, but whales. The large cetaceans that populated the warm shallow seas of the Miocene and Pliocene epochs, seas that were warmer and more productive than today's oceans, full of the baleen whale ancestors that Megalodon had been co-evolving with for millions of years. Whale bones from this period frequently show deep, parallel gouges matching megalodon tooth geometry and bite marks consistent with the shark attacking the fins and flukes, immobilizing the whale before moving in for the kill. This is not speculation. It is written into the fossil record in marks of calcified bone. The megalodon went extinct approximately 3.5 million years ago. The cause is debated, but most evidence points to a combination of factors: the cooling of the oceans as Earth's climate shifted, the retreat of the warm, shallow seas that had supported the whale populations Megalodon depended on, the diversification of competing predators, and possibly a supernova event evidenced by elevated radioactive isotopes in seafloor sediments at this geological boundary that may have increased radiation at surface ocean levels, affecting marine food chains. Megalodon is not alive today. This is worth stating plainly because the question arises reliably. The ocean has been surveyed, acoustically mapped, photographically documented at every depth. Megalodon-sized animals cannot hide in the modern ocean. The food chains that supported them no longer exist. The warm, shallow seas are gone. A modern ocean could not sustain an animal of Megalodon's metabolic requirements. What remains is the teeth, and the image, and the shadow it casts across our imagination of the sea. That shadow is real, even if the animal is not. Megalodon shaped the ocean in ways we are still tracing. In the evolution of whales that grew larger and faster to escape it, in the ecological relationships its absence created, in the simple fact that for approximately 20 million years, it was the most powerful predator on the planet. The ocean it left behind is the one we now share with its distant living relatives. They are, when in their own rights, extraordinary, but they carry the shadow of what came before. What the ocean keeps, the ocean does not sleep. While you rest, the whale shark opens its great mouth and draws in the sea's small offerings. The Greenland shark drifts through the Arctic dark at the pace of a slow tide, 3 centuries old, or 4, or perhaps 5, measuring its life in a different kind of time. The hammerhead sweeps its wide head across the seafloor, reading heartbeats through the sand. The great white hangs in the mid-water column between one breath and the next, and simply exists. Whence we came tonight to meet them. These animals, built by 400 million years of trial and refinement, each one an answer to a question the ocean asked. Each one a proof that survival is possible in ways we would never have invented on our own. There is something comforting, perhaps, in knowing they are out there, that the deep water is not empty, that while we occupy our small warm spaces above the ocean's surface, something ancient and vast and perfectly at home is moving through the dark below. We did not make the ocean. We did not design the shark. We arrived late, and we will stay only briefly in geological terms. And in the time we have, we get to know that these creatures exist, that they matter, that the blue world is richer and stranger for their presence. Let your breathing slow to the rhythm of deep water. Let the weight of the surface world release. Somewhere below you, something enormous and patient is moving through the dark. It is not afraid. It has never been afraid. It has been in this ocean long before the word ocean existed. And tonight, it keeps you company. Sleep well.